Hi, good morning, everyone. So my subject is compiler design. So in that, I'm going to explain the rule of lexical analyzer topic. So first, we need to understand that what is a compiler design. So compiler design is a software which is used to convert high-level language to low-level language is called compiler design. So in that, so we need to explain briefly. So what is the rule of lexical analyzer? So this is a diagram for the rule of lexical analyzer. In this diagram, we are going to see that lexical analyzer, parser, symbol table, and the semantic analysis, source program, tokens, and get next tokens are there. The lexical analyzer, it takes the input as a source program, it reads the character by character, and it produces the stream of token. The main rule of lexical analyzer is it takes the input as a source program, it reads the character by character, and it will produce the stream of token, and it reaches to another phases that is called semantic analysis phases. Again, that parser is a request to another token. So this is this arrow mark. So here, so once you receive the token, again this parser again it will give the request to the lexical analyzer for next token. Again, the lexical analyzer it reads the another characters and it will produce the stream of tokens. And this information stored in the symbol table. The symbol table means it is used to store the information about identifiers. So now let us discuss the why to separate lexical analyzer and parsing. There are three advantages are there to separate the lexical analyzer from parsing. So the first three advantages is the simplicity of design, and second one is improving the compiler efficiency, and third one is enhancing compiler portability. So by separating the lexical analyzer from the semantic analyzer, so first advantage is to simplify the design. Easily you can design the softwares. So improving the compiler efficiency means easily within a short time, and within a short time, the compiler will compile the source program. The enhancing compiler portability means so you can carry the compiler from one OS to another OS. This is the three main advantages of separating from lexical analyzer to parsing. So what I mean by tokens, patterns, and legends. Tokens is a pair of token name and optional token values. Token values called as an attribute values. Token name and attribute value or token values. A pattern is a description of the form of the legems of a token may take. What is the legems? Legems means is a sequence of characters in the source program that matches the patterns for a token. So first let us discuss what is a token. So tokens is a sequence of characters, and it will give the meaningful word that is called a token. So token contains the two parts. One is called token name, and another field is called attribute value or token value. A pattern is a description of the form of that legems of a token may take. Then what is the legems? Legems is a sequence of characters in this source program that matches the pattern for token. Now example, let us discuss the example. The first token, you can see this tokens, see this table, token, information description, sample, legems. Tokens are if, else, comparison, ID, numbers, and literal. The informal description means the if the characters are I and F, and else the characters are E, L, S, E. The comparison less than or greater than or less than or equal to, greater than or equal to or not equal to. So ID means the letter is followed by letter and digits, and number is any numeric constant. Literal is anything but surrounded by quotes. That is called literal. Sample example you can take if, else, less than or equal to, not equal to, and pi score D2. So these are the numbers like 3.14 and 6.02 exponential value. That's 6.02 E23, and this literal value is a code dump. So total inclusive this one example of printf is equal to printf. The total is equal to percentage d comma score. So this is the example of tokens. Now attributes of for a tokens. Attributes of a token means what? So to give the attributes value to the tokens. So first you can take example is equal to MC square. So how to write in the languages? E is equal to m star c star star 2. That means E is equal to mc square. First ID. ID pointed to a symbol table entry for E. So E is the entry table symbol. E is pointing to the symbol of entry table for E. Then assign optional. So ID. Next ID is pointed to symbol table entry for M. So this is another variable that's called M. So you can take this as an ID too. Another one is pointed to the symbol table entry for C. Number or integer value is called 2. So this is an example for tokens. Now let us discuss what are the lexical errors. Some errors are output of the lexical analyzers to recognize. So if a is equal to f of x, instead of that what we written, so f5 we have written. So that is one kind of errors. However, it may be able to recognize the errors like d is equal to r square. So instead of that d is equal to r square, you written d is equal to 2r. Such errors are recognized when no patterns for tokens matches a character's sequence. Now, error recovery. So let us discuss another topic which is called error recovery. The panic mode. The panic mode means successive characters are ignored until we reach to a well-formed token. Panic mode means the successive characters are ignored until we reach to a well-formed token. So delete one character from the remaining input and insert the missing character into the remaining input and replace the character by another characters or transfer two adjacent characters. So in this way you can recover the errors. So let us discuss first on panic mode. So how to recover the errors, once you get a error, then how to recover them. So first the panic mode, the successive characters are ignored until we reach to a well-formed token. The second uh, the second one is delete one character from the remaining characters. Third one is inserting the missing character into the remaining input. And next option is the replace the character by another character. The transpose two adjacent characters. So this is way to recover the errors. So now let us discuss another topic is called input buffering. So input buffering. So sometimes the lexical analyzers needs to look ahead some symbols to decide about the token to return. So take the C languages. In C languages, we need to look after equal or less than to decide what token to return. So now do 5 I is equal to 1.25. So we need to introduce the two buffer schemes to handle the large look at safety. Two buffer schemes. What are the two buffer schemes? The first one is called Lexical begin pointer. Then second one is called forward pointer. So now take the whatever the language you written in code in whatever the language you will write, so that you can store it into the memory. So how you can store it in the memory? So this is the picture. So what I'm going to show here. The code is saving in this format. So E is equal to mc square. That means E is equal to m star c star star 2 at finally end of the file. So now here the lexeme begin pointer is pointing to the first character of the lexemes. Again, forward pointer is pointing to the first character of the lexemes. Then forward pointer is pointing to the next characters. So move on. It's moving next character until reach the end of the file. When moving the next characters, it will reach the space, white space. Then compiler think that so we have reached end of the token. Then it will produce the one token. Again, it's begin to the lexeme begin pointer is pointing to the next characters. Then forward pointer pointing to the next characters. Then moving next character is finally to reach the end of the file. Then it will produce the another token. So now this is an algorithm for input buffering. So switch star forward plus plus. Here using postfix operators. So case end of the file. If forward is at end of the first buffer, if forward is at end of the first buffer, reload second buffer. Then forward is equal to begin of second buffer. Else if. Now we go for else if. Else if forward is at end of the second buffer. This is the first buffer. Else part is in second buffer. If forward is at end of the second buffer, then reload the first buffer. Then forward is equal to beginning of first buffer. Now break. So case for the other characters. So based on your applications, you can write on the cases. So this is about input buffering. Now let us discuss the specification of tokens. Specification of tokens. In this theory of compilation, regular expressions are used to formalize the specification of tokens. The regular expressions are means for specifying the regular languages. Example, letter is followed by letter or digit star. Letter is followed by letters or digit star. That means one letter is followed by letter or one digit, or one or more letters, one or more digits. Each regular expression is a pattern specifying the form of strings. So see the regular expressions. Here we are using the epsilon is a regular expressions. If the symbol is sigma, then is a regular expression is equal to regular expression. So L of A is equal to A. Then R symbol S is the regular expression denoting the languages L of R union of L of S. Then RS is a regular expression denoting the regular expression of. So you need to specify the L of R from L of S. Then R star is the regular expression and R is the regular expression for LR. So here extensions we can understand that the plus means one or more instances. That means question means zero or one instances. The just see the character classes is ABC. So take example letter. So letters are it may be capital or small. So A to Z, A to Z. Digit may be 0 to 9. ID means letter is followed by letter or digit. So next topic is recognition of token. Recognition of tokens. The starting point is the language grammar to understand the tokens. The statement if expression then statement or if expression then statement else statement or null or epsilon. Then expressions may be term or reloop term or term. So term may be ID or number. The next step two is the formalize the patterns. So digit equal to 0 to 9. So 0 to 9 digit implies that means digit equal digit plus. That means digit means single value. So digit plus means you can take one or more values. That means 10, 20, 30, 40. So numbers means digit dot digit. That means here you can take the number maybe sign plus sign or minus sign, then digit. This is the syntax. Then letter is capital letters or small letters. ID is letter is followed by another letter or digits. If means if, then else, else. Then reloop means greater than or less than, greater than or equal to, less than or equal to, or equal to. So let us see the transition diagram for loops. To start, you can take these are called states. 0 is in start state, and here 2, 3, 4, 7, 8 is the end state or final state. So first I'm passing as a input as a less than symbol, it goes to another state that is called 1. Again I'm passing equal as another input, it goes to another state that is called 2. So this is 2 is called final state. It will return the what less than or equal to. There. So in this first state, again I'm passing greater than. So it will produce not greater than equal to. So other means you can pass as a null. That means it will produce less than or equal to. So here in the first state, I'm passing equal as an operator. It will give the reloop or equal operators. Then here in the beginning state, I'm passing greater symbol as an input. It goes to state number 6. Then again, I'm passing equal operator in the sixth state. It goes to another state that is called seventh state. Seventh state is called as a final state and return the values equal greater than or equal to. In the sixth state, I'm passing as a null. Other statements as a null, it goes state, it will return greater than. So same another diagram for this. See this transition diagram for reserved words. So reserved word means reserved words and identifier. Reserved words are keywords and identifiers are any variable name. So in this state, I'm on state given name as a 9. So I'm passing on letter as an input. It goes to next state. Again in this state, I'm passing on letter or digits. It doesn't go anywhere. It is in same state. That means self loop. And if I pass other character, if I pass as a null, then it goes to another state. It will produce the get token or instance ID. So same transition diagram for white spaces. Transition diagram for white spaces. Start in the starting symbol. I'm passing as a delimiter. Delimiter means it's in white spaces, tab spaces, null characters. Total you can call it as one word is called delimiter. So delimiter, I'm passing as an input. It goes to 23 state. Again, if I pass the delimiter, it doesn't go anywhere. It's in same state. Then if I pass another character, that means an epsilon or null, so it goes to another state that is called 24. That is called final state. So now let us discuss the lexical analyzer Lex. So Lex is a software tool which is used to execute the Lex programs. So Lex program, how to say the Lex program? By using .l. The format of saying the Lex program is .l, file name .l. So lexical analyzer, so take as an input as a Lex program. In Lex analyzer phases, it takes the input as a source program. The source program may be C program, any high level languages. Here I given as a lex.l. Lex.l means Lex programs. Then it will produce the output as a lex.yy.c. Then C compiler takes the input as a lex.yy.c and it will produce the output as a dot out. That means you can pass the input stream, it will produce the sequence of tokens. So this is the way of lexical analyzer works out. So it takes the input as a source program, it will produce the output as a sequence of tokens. Then structure of Lex programs. So structure of Lex programs is first structure is declaration. So in the declaration part, you can declare any C variables and you can declare any preprocessors of C languages. And transition rules are here. Transition rules you can contain two parts: pattern and action. So patterns may be regular pattern matches with our pattern specifying the regular expression, then action specifying the C programming languages. Then whatever we are giving the input, it will matches with the pattern. The input will matches with the pattern, then corresponding action will be executed. Then auxiliary functions, that means void main or any other functions you want to write, you can write it in auxiliary functions. Thank you.